name is Matsuoka, and I'm going to teach you how to make rational functions based off of different properties. This is the exact opposite of my previous video that was like properties of rational graphs. So in that video, we really I was given an equation and then you were trying to find all this stuff. Now you're given all this stuff and you're trying to go backwards and find the equation. So I'm just going to warn you right now, if you don't know how to do that stuff really well right now, you need to go back and watch the other video so that you can get a better idea of what everything is and where everything comes from, so you could do better with this stuff. So the very first thing that we're going to do is we're going to put the vertical asymptotes in the denominator because that's where they come from. Then we're going to put the zeros in the numerator because that's where those come from. The next thing we do is we put the holes in both the top and the bottom because the holes come from what you cancel out, so they have to be in both. Then you're going to check the horizontal asymptote to make sure that that's correct. Lastly, you're going to plug back in to check and make sure that the holes are good. So, first one is this. We got y equals. On the bottom is going to be x. On the top is going to be x minus 2. And on the top and bottom is going to be x minus 1. Okay, now we're going to look at that horizontal asymptote because we've done the first 3 steps. Horizontal asymptote is none. However, right now it's 1 because, they have the same exponents, so we need to make the exponent on the top bigger. So I'm going to go ahead and try to square this first one in order to make the exponent bigger. Now the exponent is basically 3 on the top and just 2 on the bottom because I have 1, 2, and 1, 2, 3. So I'm going to check in with the holes. So I get this x minus 2 squared. Those will cancel over x. So I'm going to get 1 minus 2 squared over, and that's going to be 1. So that's going to be 1 minus 2 is negative 1 squared over 1. So that gives me positive 1, which is exactly what I want here. So that is my first equation. Alright, on to the second one. The second one, starting off the same way, it's y equals. On the bottom, we're going to put x plus 1. On the top, we're going to put x. And on the top and bottom, we're going to put x plus 3. So here, we're going to look at the horizontal asymptote. It's y equals 0. So if it's y equals 0, then we need to square something here on the bottom though, because now we need the bottom exponent to be bigger than the top. So looking at this one here, let's see, we could let's square the second one, see if that works. So if we square the second one, we're going to simplify. I got x, that will cancel out with one of those, and it'll be x plus 1, x plus 3. Now you plug in, we get negative 3 over negative 3 plus 1, negative 3 plus 3. Well, negative 3 plus 3 is 0, but we can't divide by 0, so this one doesn't work. So we know right now we cannot square the first one. We're probably going to have to square the second, or can't square the second one, we probably need to square the first one. So let's just double check there and make it squared there. So let's go ahead and do this. We're going to cancel those out. We get x over x plus 1 squared. On the top, let's see, I'm going to get negative 3. On the bottom, it's negative 3 plus 1 squared. So I got negative 3 on the top in total. On the bottom, it's going to be a positive 4, which is exactly what I wanted to get. Now on these first two, you can be pretty creative here. You definitely don't need to be, but these are just the basic equations that you could have. If you wanted to, you could make this squared a cubed or the 5th power or whatever. You could also change this exponent here if you really wanted to as well. But the main thing is that the bottom exponent has to be bigger than the top in this one. The top exponent has to be bigger than the bottom in that one. Because there's no horizontal asymptotes, if you really wanted to, you could put coefficients in front as well. But yeah, you don't need to. I think the basics is just fine. Okay, here's the last one. So the last one, again, it's y equals. On the bottom, we have x minus 4, we have x plus 3. On the top we don't really have anything. On the top and bottom is x minus 2. And right there. So now we check that horizontal asymptote. It's at y equals 2. Right now it's at y equals 0 because the top exponent is smaller than the bottom exponent. So that means we need to raise this to the third power here. That would make it 1. Now we need to put that coefficient in there. We're going to double check with the whole to make sure it's correct. So to do that, we just cancel stuff out. We get 2, and then x minus 2 squared on the top. On the bottom is x minus 4 times x plus 3, and now I just plug in. So I get 2, and then 2 minus 2 squared over 2 minus 4 times 2 plus 3. On the top, we get 2 times 0 over negative 2 times 5. 0 times anything is just 0 though. So we're good, because that's 0. Alright, I guess the most important thing to take away here is when I'm saying you plug back in to check the holes, we're pretty much doing the same thing that you did when you found the holes earlier. So you're really looking to confirm that y coordinate. So you're plugging in the x coordinate for x, you want to end up getting your y coordinate here. Okay? That's pretty much it for our examples. I will give you a bonus question, and that will be it. Here's your bonus question. So you're given the following information here, and you want to make an equation. Go ahead and make sure you're following all the steps, and definitely make sure you're plugging back in to check the holes, and then make any adjustments that are necessary to make sure that the hole is correct. Alright, good luck!